In this question, it is saying that there is a gas of n equals 1, number of mole is 1, whose volume is given as V equals 0.83 meter cube, and gas is at temperature T equals 100 Kelvin. This is our piston, which is movable piston in this question, of course, whose area is given as 10 power minus 2 meter square, and there is a spring connected with this piston, which is spring constant K is 100 Newton per meter. Okay. These given data R equals 8.3, and it is saying that first of all this system is in equilibrium. Okay. Now this gas pushes the spring further by 0.1 meter, and in this process, by pushing this spring by 0.1 meter, what is the work done by the gas? It is asking to find. Now you see, first of all we will have to calculate at equilibrium what was the compression of this spring. So at equilibrium, of course the force must be, net force must be 0. So a spring force, okay, must be equal to force applied by gas, which will be of course pressure of gas multiplied with this piston area. Okay. This will be what? Kx. Okay. F spring is what? Pressure into area. F spring is Kx. So Kx, let us suppose this one is x1 compression, Kx1 will be equal to pressure, and pressure will be what? Pb equals nRT. From gas equation, pressure will be nRT upon V, nRT upon V multiplied with area A. From this equation we can get initial compression of the spring. So x1 will be simply, n is what? 1, R will use 8.3, temperature will use 100 Kelvin multiplied with volume, which is initial volume 0.83 multiplied with area, which is of course 10 power minus 2. By solving this, you see here this 2 will gets cancelled, and this will be simply 10. Okay. So x1 will be 10 centimeter. Okay. So we can write it as x1 equals 0.1 meter. Okay. It is saying that this gas is pushing it again by 0.1 meter distance. So further x2 must be 0.1 meter plus 0.1 meter, that is 0.2 meter. You see, work done by gas must be equal to the potential energy stored in this spring for the section when it was earlier compressed by 0.1 and now it becomes compressed by 0.2. During this extra 0.1 compression, the potential energy stored by spring must be equal to work done by the gas. So work done by gas will be equal to change in potential energy, that is half K x2 square minus x1 square. Okay. So it will be half multiplied with K is what? K is 100, x2 is 0.2, so 0.2 whole square minus 0.1 whole square. By solving this, we get 50 multiplied with 0.02 whole square is 0.04 minus 0.01. So this will give us 50 into 3 upon 100, which will be equal to 1.5, and we can write it as 1.15 multiplied with 10 power minus 1. This is what work done by gas in joule. You see, in the question it is given that work done by gas is N multiplied with 10 power minus 1 joule. So by comparing these two, that is result of this with this, we can get finally N equals 15. So this is our desired result for this question asked.